All right, it's time to take a look at periodic table. This is going to be a general overview. We're going to be looking at the trends of the periodic table of the elements for the purposes of understanding it the way that an eighth grade science student should understand it. So here's the periodic table of the elements that we're going to be ultimately responsible for knowing about. This is the one that is used for North Carolina public schools for any sort of chemistry related questions from now until when you graduate high school. You'll be seeing the same one in one form or another. You might end up with more elements over here, but this is going to be the same layout. Lots of different types of periodic tables depending on what you're looking at. This is the one that we're going to use. Now, the reason why students do poorly at the periodic table is that this is a lot of information. This is a lot of information and it's not very comprehensible, and so we need to simplify it. That's what we're going to start off with, is we're going to simplify it, and the first way we will simplify it is by getting rid of the bottom. At the bottom of the periodic table are two periods. Periods are rows. The first period is rare earth elements. These are called the lanthanide series, and for our purposes, we don't need to know hardly anything about them. The row underneath them are the actinide series, and the actinide series is made out of three elements that are radioactive. Uranium at number 92 is the last element that's naturally occurring on the periodic table. After number 92, numbers 93 to 103, those are all synthetic. Synthetic means human-made. These do not occur in nature. These human-made elements we don't need because they don't really exist in the world. Since we're studying the basics of chemistry, we don't need to burden ourselves with this extra information. There's more synthetic elements up here from 104 all the way up to 112. So let's just get rid of all of these. There. So we simplified the periodic table a bit. Now we still have this top half, and this top half certainly has a lot of information on it. So what we need to do is consider that we don't actually need to know the names of all of these elements. We just need to know the general trends around them. If you ever need to know one of these elements, really, you don't need to know these. Do not memorize them. They are wasted. That is a waste of your time and mental energy. If you ever need one of these elements, you can certainly refer to the periodic table to find out about that element. So let's not worry about these elements. Let's get rid of them. Here's how we're going to get rid of them. So here's our periodic table. This is what we actually need to know about. So that means that we're thinking about atoms. Now, when we're thinking about atoms, we're going to be thinking about the basic unit of matter. The smallest piece of matter is an atom. An atom is going to be the smallest piece of something that's going to have specific physical and chemical properties. Now, once you build out from that, then you're no longer talking about atoms, you're talking about molecules, compounds, or mixtures, which is not what this presentation is about. Now, specific types of atoms are called elements. These elements are going to have specific physical and chemical properties. So we're no longer saying we want an atom. We're saying we want a red atom, or we want a green atom, we want a yellow atom, or we want a blue atom. These would be four different elements, four atoms each of the four different elements. So an element is an atom with specific physical and chemical properties. The periodic table organizes elements. Elements that are arranged in the same column as another element are going to be chemically similar. Columns on the periodic table are called groups. Rows on the periodic table, rows go back and forth. Rows on the periodic table are called periods. We're going to be much more concerned about groups than we are with periods because groups are chemically similar. And that's going to be helpful because now instead of having 92 different elements, we're going to have elements grouped into 8 large columns and then these 10 shorter columns in the middle. And we can deal with all of those together. So in general, we're going to have elements that are classified as metals, which are going to be all the gray elements here. Non-metals, which are all the shades of blue, and then metalloids, which is this yellowish color. The metalloids are going to go down that staircase of science that is in bold on your periodic table. Now, transition metals are in the middle bit. This is the middle bit of the periodic table. Transition metals are important. They're going to be economically important. They're important for engineering. They're important for chemistry, but they're as elements, they don't behave as predictably as these 8 main groups do. And so for 8th grade purposes, we're mostly going to ignore the transition metals in favor of studying groups 1 through 8. So that's where we're going to go from here. Metals in general, so all of the gray elements, are going to have similar physical and chemical properties. They're going to be dense, malleable, ductile conductors, meaning they move heat and electricity through them efficiently. Malleable, you can hammer them out into sheets. Ductile, you can twist something into a wire. They're going to have a high melting point and also a high boiling point. This makes it so that almost all metals are going to be solids at room temperature. Some metals are magnetic. Really only 3, iron, nickel, and cobalt are magnetic. They're going to be around here someplace. Non-metals, inversely, because inversely they are the opposite. Non-metals are going to be less dense. Non-metals are brittle. They crumble if you find a picture of sulfur or you Google videos of sulfur, it crumbles into a powder because it's a non-metal. So they're not dense, they're brittle, they're insulators. They block the transfer of heat and electricity. They have a low melting point and a low boiling point. They have such a low melting and boiling point that some nonmetals are actually gases at room temperature. All of these dark blue elements are all gases at room temperature. Now, metalloids in the yellow, these are going to be elements with a combination of metal and nonmetal properties. More specific to metalloids is the semiconductor property. A semiconductor is going to be the most important physical property of metalloids because it's different from metals or nonmetals. Semiconductor means that this will conduct heat and electricity under specific circumstances, and it will not under other circumstances. So semiconductors are really important to us. Semiconductors are going to be the important physical property for metalloids. Now, for groups 1 through 8, we have some properties to keep in mind. Group 1, 2, 3, and 4 are going to lose electrons to become more stable. They lose electrons from their valence shell. That's going to be the outside electron shell of the atom. And they're going to become more positive as they lose electrons. Now, groups 4 through 7, those are going to gain electrons to become stable. They're going to gain electrons to get up to 8 electrons in their outside or valence shell. That's going to make them more negative over time. Group 8 already has 8 electrons, and so it's not going to do anything. It's going to remain neutral. Now, group 1 and group 7 are going to be the most reactive metals and nonmetals respectively because they're only losing 1 electron or gaining 1 electron, which isn't very difficult to do. So they're able to easily gain or lose that electron and stabilize from there. So they're very reactive. Your most reactive metals are number 1, most reactive nonmetals are number 7. Group number 1, the most reactive metals are called alkali metals. Group number 7, the most reactive nonmetals are called halogens. Group number 8 is significant also. Group number 8 is already having 8 electrons. It's already stable, and so it will not gain or lose electrons to become stable because it doesn't need to. Since it's already neutral, it's not going to chemically combine with anything because it's not going to have a charge that would attract or repel from something else. So these are going to be your noble gases. Noble gases are group 8. Alkali metals, once again, just to reiterate, alkali metals are your most reactive metals. Halogens are your most reactive nonmetals. Noble gases are your non-reactive gases. And this is the base information that you need for the periodic table. I hope that this was helpful, and I hope that you proceed well and are quite successful in all of your science endeavors.